quick lesson on recurring decimals. So the first question is, where do they come from? And we can figure that out if we have a look at some bus stop division. So let's take a third, for example, and we know that is 0.3 recurring, or if you like, 0.3333, and the 3's going on forever. So we just put dot 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 to show that they continue on forever. Let's look at the bus stop division and just see where that's coming from. So if we take 1 and divide it by 3, 3 goes into 1 no times. Okay, we've got to start remainders. Remainder 1. So let's put in a decimal here. Let's start putting some zeros in. 3 goes into 1 no times. Remainder 1. 3 goes into 10 3 times. Remainder 1. 3 goes into 10 3 times. Remainder 1. 3 goes into 10 3 times. Remainder 1, and so on and so on and so on. So you can see where that recurring decimal is coming from. Let's compare it with a number that doesn't have a recurring decimal. So for example, a quarter, which we know is 0.25. When we do the bus stop division for this, look what happens. 1.00. 4 goes into 1 no times. Remainder 1. 4 goes into 10 twice. Remainder 2. 4 goes into 20 5 times, no remainder. So that terminates and we've got an exact decimal. So the first thing for me to get you to think about is, how can we spot the fractions that will give exact decimals? How can we spot the fractions that give recurring decimals? Anyway, that's for you to think about, and we'll talk a bit more about it in the lesson. Let's do some examples now of how you can convert a recurring decimal back to a fraction. So a fresh page. So let's start with a nice easy one. Always a good place to start. Let's take the recurring decimal, 0.5 recurring. Okay, so we're going to try and convert that into a fraction. Right, well the first thing is, let's say let x be that recurring decimal, 0.5 recurring. I'm going to write it like this, 0.555 dot dot dot, so you get the hang of the numbers. And we want to convert that into a fraction. To do that, we look at 10x. So take that x value, times it by 10. That would be 5.555. And then all we've got to do is a little subtraction here. So if we work out 10x, take away x, that would be 5.555 recurring minus 0.5 recurring. And we can see that that would be 5, because this 0.5 recurring here is what we've got here after the decimal point. So this is going to get rid of all of those numbers after the decimal point there. So we've got 10x take away x, which we know is 9x. And now we've just about got this cracked, because x is obviously 5/9. Okay, let's move on. Let's do another example. The examples are going to kind of build on each other. So let's have a new one. Okay, so what about this one then? We want to take the number 0.63 recurring. Now the dot is above the 6 and above the 3. So what that means for our x is that it's going to go 0.636363, and so on and on and on like that. Okay, so we want to try and get that into a fraction. Well, ideally what we want to do is to move this decimal point down to, so that we've got after the decimal point 6363 happening again. So to do that we're going to need to find out 100x, find the value of 100x. So that would be that would be 63.636363 and so on. Now if we take 100x, and subtract x, we'll be doing this. We'll be taking 63.636363 and so on, and subtracting 0.636363. Repeat it. So on this side we're going to have 99x, and on this side we're just going to have 63, because all of this is just what's here after the decimal point. So now we can say x is 63 over 99. But don't stop there. If you can see a way of cancelling down that fraction, simplifying it, then you should do. So we can see 9 goes into 63 7 times, 9 goes into 99 11 times, so there is our simplified fraction. Right, next one, next question, next example. Here we go. 0.132 recurring. So the 1 recurs, and everything between the 1 and the 2 recurs. So that means that x is 0.132132, and so on, carrying on like that. So to work out this one, we need to find 1000x, which is 132.132.132.132, and so on. And the reason we found 1000x is because we want the numbers after the decimal point to be the same as these numbers here. So by moving them along 3 decimal places, we've done that. Okay, so then we want 1000x, take away that x, which is 132.132.132, and so on, minus 0.132.132, so on. 999x on this side, and 132 on this side. So now we have x equals 132 over 999. There's our fraction. Does it simplify? I think it might actually. If we divide by 3, we'll get 44 on that side on top, and 333 on the bottom. Okay, last one I'm going to do. Probably the trickiest one of them all, really. So, sometimes you get a decimal like this, 0.546, and the 4 and the 6 are going to occur, but the 5 doesn't. So that means x looks like this, 0.5464646, and so on. So to get that as a fraction, we'll have to be quite careful here. Let's find 1000x, which would be 546.464646, and let's find 10x, which would be 5.464646, and so on. Okay, so now hopefully we can see that by subtracting, we are going to get rid of all of this decimal at the end here. We're going to get 1000x minus 10x equals 546.46 recurring minus 0. Sorry, go back a step. 5.4646 recurring. Okay, when we do that subtraction on this side, we get 990x. On this side, 546 minus 5 is 541, and the decimals cancel. So now we've got x is 541 over 990. There we go.